بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Assalamu alaikum wa rahmatullahi wa barakatuh. I would like to welcome my students from grade 12 into their third video regarding online lessons. And in the previous lesson, we talked about permutations. We've discussed some of the ideas that we have in that lesson. And we delayed some of the other ideas. We said that we will delay the ideas of word problems until after we finish with today's lesson. So the third lesson that we have in this chapter, chapter 2, is 2-3, which is combinations. And this is going to be the lesson that we will be discussing today. Now, of course, you can find this lesson in the blue book. Exactly in this book. You can find the lesson in this book, the blue book. And this lesson is going to be, of course, in chapter 2. This lesson is 2-3. So you will find the lesson in, the lesson starts on page 84. The lesson starts here on page 84, and the exercises of this lesson are going to be on page 92. So your homework today, inshallah, is going to be on this, from this exercise 2-3, which starts at page 92. Okay, so what do we mean exactly by combinations? And what is the difference between combinations and permutations? Now, you might remember that we said earlier in the previous class that when you have a permutation of 2, for example, then the answer in this case is going to be 2 actions. The first is 4, and then this next consecutive number is 3. So permutation 4-3 is going to be 12. But what does that mean exactly? We've discussed in the introduction of permutations that in permutations, we're interested in selecting 2 elements out of 4 elements, and then not only selecting them, but we always care about select, and then after we select, we arrange. And we want to know in how many ways can that be done. So let's elaborate on this a little bit. So, for example, let's say that you have these 4 numbers, 1, 2, 3, and 4. Now, our question is, in how many ways can we select and arrange 2 numbers out of these 4 numbers? So this is going to be, for sure, a permutation problem. What do we need to do? We need to select 2 out of 4, and then we need to arrange these 2. And we need to arrange them. So our question is, in how many ways can we both select and then arrange 2 elements out of 4 elements? And let's see. Let's try this out. Okay? So I want to select 2 numbers, and then I want to know how many different arrangements can we do after selecting these 2 numbers. So let's say that I selected 1 and 2 first. So if you select 1 and 2, you can have 2 different arrangements. You can either write 1 and then 2, so you have 12, for example, or you can write 2 and then 1, so you have 21. And these are the only 2 options you have. So the first thing we selected was 1 and 2. Why not we select 1 and 3? See, if we select 1 and 3, we will get either 13 or 31. So these are the only 2 options we have. Okay, what if we select 1 and 4? Now if we select 1 and 4, we will get either 14 or 41. And in permutations, we cannot repeat. Always remember that we cannot repeat in permutations. Now we've selected the one with the 2, the one with the 3, and the one with the 4. So I think we're done with the 1. Now let's try with the 2. So we can select the 2 with the 3, right? The 2 with the 3. So we can get either 23 or we get 32. We can select either the 2 with the 4. Now if we do that, if we select the 2 with the 4, we can either get 24 or 42. Now always remember, what are we doing? We're selecting first, and then after selecting, we're checking the different arrangements we can get. So we select 2 numbers and then we arrange these 2 numbers to see how many different arrangements we can get. Now we've selected the 2 with the 1 previously, the 2 with the 3, and the 2 with the 4. So we're done with the 2. Now the only option we're left with is the 3 with the 4. So the 3 with the 4. Now if we select the 3 with the 4, we will get either 34 or 43. These now are all the different possible arrangements of 2 elements out of these 4 elements. We have in this set 4 elements. Now we're going to select 2 of these 4 and then we're going to arrange them. So these here in front of you are all the different possible arrangements we can get. And let's count them out. So they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 arrangements, and that's the same answer we got from the permutation. Okay, now let's inspect this problem again, but this time let's say that we want to know in how many ways we can select 2 numbers, but then we don't care about arranging them. So we just want to select them. We want to select 2 numbers out of 4 numbers, and we want to know in how many ways can that be done. So I have this set. In how many ways can I select 2 different numbers from this set? Select them only and do not arrange them. So this time, since we are not really interested in arranging them, then we are actually looking into the subsets of this set. The parts of this set that consist of 2 elements only. Now look at this. We can take 1 with 2. But now it doesn't matter, it doesn't really make sense or make any difference that we write 2 and 1, because this is a subset. We don't care about arrangement. We just want to select 2 numbers, that's all. That's what we want. Now this is 1 and 2. We can select 1 with 3. We can select 1 with 4. Good? Then we can select what? We can select 2 with 3. And we can select 2 with 4. Good? And then we can select 3 with 4. Now, always remember that if you write 2 and 1, it doesn't make it any new answer. It's 1 and 2, 2 and 1 are the same thing, because arrangement this time is not important. So here we want to select only. We don't want to arrange. We just want to select 2 numbers. So if you want to select 2 numbers from these, you can get either 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, or 3, 4. And the number this time is down from 12 up to 6 only. Now this number is not going to be a permutation, because in permutations, we select and then we arrange. This time we don't want to arrange actually, we just want to select. So this number here, the six possible answers, is going to be what is called a combination. So this can be expressed as a combination of 2 elements out of 4 elements. Okay, so guys, look at this. In the previous one here, the permutation of 4 and 2 elements there means that in how many ways can we select 2 elements and then arrange them. So we want to select and then arrange. How many different arrangements can we get, okay? So this is called the permutation. In permutation, we both select and arrange. But in combination, we really don't care about arrangement. All what we want to do is to select two numbers out of 4. So here in this one, we expressed it as combination 4, 2, and as you can see from the example that we've just put, this is going to be equal to 6. Good? So this is basically the difference between permutations and combinations. In permutations, we care about the arrangement, so we want to select and then arrange. But in combinations, we only care about selection. So we want to select two numbers and that's it. We don't care about how do they arrange afterwards. So you can notice a couple of important ideas here. Always notice that the number of combinations is always less than the number of permutations. And that should make sense to you because in permutations we select and then we arrange. So with these arrangements we will have many arrangements from the same selection. Notice that these two permutations are actually one combination. These two arrangements are actually taken from one selection. And these two permutations or these two arrangements are taken from one selection. And these two permutations are taken from one selection. So each one selection gives us two permutations in this example only. So that's why you will always notice that the permutation of NR, that the combination of NR, if you can say, is always less than, in some cases equal to, permutation of NR. So this is the first note that you need to notice. Okay, so let's see. Now let's continue. So I need you to write the following in your copybooks. So this is the title, 2-3, Combinations. And the first thing, I want you to write this notes. So, the first note we have is that in permutations, we select and then arrange. We select and then arrange our selection. So you don't only select elements, you select them, and then after you select them, you need to arrange them as well. But however, in combinations, we only select elements, or choose, if you like, choose elements, while their arrangement is not important. And the third thing, you need to notice that the combination of N, R is always less than or equal to N permutation R. Good. So this is the first thing that we need to know. Okay. Now guys, now let's see. So how do we evaluate a combination? In the previous lesson, we learned how do we evaluate a permutation. So, for example, all of you know now, when you want to evaluate 4 permutation 2, what you need to do is draw two actions and then start from this number 4. So it is 4 times 3, which is 12. But how do we evaluate a combination this time? How do we get that combination 4, 2 is equal to 6? How do we calculate it? So, to do that, we need to look into the relationship between combination and permutation, and also combination and factorial. So this is the first thing that we will be discussing now. The first thing that we will talk about, please write this as well in your notebooks, it's the relation between combinations and permutations. Okay. So, this is quite an easy relationship. And it states the following. Look at this, guys. Whenever we have a combination of n elements and you want to select or choose r elements from the n, this is going to be equal to n permutation r divided by r factorial. So let's see. Let's put this now in as a formula. So this formula suggests simply that when you need to find n combination r, you need to find permutation n r and then divide it by r factorial. And let's show you that with the previous example. So an example, in the previous one, we actually calculated 4 combination 2. And the answer was 6. Let's see, following this rule, will we also get 6 or not? Let's see. So this is going to be what? It's going to be 4 permutation 2 over 2 factorial. It is n permutation r, 4 permutation 2 over 2 factorial. Now, 4 permutation 2 means 2 actions starting from 4 and then to 3. So that's 4 permutation 2, 4 times 3. Over 2 factorial is going to be 2 numbers that start with 2. So it is 2 times 1. Is this good so far? So this is going to be 2 times 1. And now what do? We cancel what is possible. So we can cancel the 2 with the 4. We get 2. So we get 2 times 3, which is 6 over 1, which is basically 6. So this is the same answer that we figured out before. But this time we actually calculated this by using the relationship between permutation and combination. Okay. Now the second thing that we need to investigate is the relationship or the relation between combinations and factorials. In the previous lesson, we discussed the relationship between the permutation and the factorial. And if you can still recall, we said actually that n permutation r is equal to n factorial over n minus r factorial. Now, we actually can have a similar relation this time, but this time this relation is going to be the combination and the factorial, and it's quite easy. It's actually taken from this. Now, you see the combination, we can write this in green until we get to the rule. So, we know that the n combination r is equal to n permutation r divided by r factorial. Good? So, now, so this means that in combination r, equals to, in permutation r is equal to this sum, to this rule. So it is n factorial over n minus r factorial. That's the permutation. And then this over, since we don't like an over and over, so we change it into divide. And then we say it's divide r factorial. And as usual, with division with a fraction, we keep the first fraction, we change the division to multiplication, and we flip the second fraction. So we keep change flip. From this one we get that the n combination r is going to be equal to n factorial over n minus r factorial multiplied by, when we flip this one, it's actually over 1. When we flip it, we get 1 over r factorial. And this means when you multiply the numerators together and the denominators together, this means that n combination r is equal to n factorial over n minus r factorial, just like a permutation, then times r factorial. And that's the added thing that we have with a combination. So this is the formula that we will use whenever we want to change a combination into a factorial. So this is now combination, the relation between combination and factorial. Please write these two relations in your copybooks. These two relations are important. The first one is the relation between combinations and permutation, and the second one is the relation between combinations and factorial. We'll take a small break now, and then we will come with some exercises of evaluating combinations using these two formulas. Okay, so we're back now, and let's now see how do we solve some exercises of combination. We will discuss now some exercises, and within these exercises we will see some properties, some further properties of permutation. So let's see. Please write this in your copybooks as well. So here we have exercises. And let's say that this exercise is asking us to evaluate. So the question is, evaluate each of the following. Okay, so the first one, we need to evaluate combination of 8 and here 5. Okay, so combination 8, 5. How do we solve this one? It's quite simple. What we need to do is we can change this. We have actually two ways to do this one. We can either use the relationship between between permutation and combination, or between factorial and combination. One of the two relations that we did before. So we can solve this as, we can say the following. So this is the answer. One way to do this is to write combination 8, 5 is actually 8 permutation 5 divided by 5 factorial. 8 permutation 5 means 5 actions that are starting with 8. So it is 8 times 7 times 6 times 5 times 4. These are 5 actions starting with 8 divided by 5 factorial, which is the sequence of all the numbers from 5 up to 1. So it is 5 times 4 times 3 times 2 times 1. Good? Now after that we cancel whatever possible. So we can cancel the 5 with the 5 and the 4 with the 4. We can cancel 3 times 2. 3 times 2 is 6. 3 times 2 is 6. We can cancel it with the 6. And we still have 1 only, and 8 times 7. So the answer is 8 times 7 basically. So the answer is 8 times 7, which is 56. Okay, so this is the first example. Let's discuss another example. Or before that, let's show you another way of solving this one. Or we can solve this using the relationship between combination and factorial. So it is 8 combination 5. So we can solve this as 8 factorial over 8 minus 5 factorial multiplied by 5 factorial. Just to remind you, the formula was n factorial. It was n factorial over n minus r factorial multiplied by r factorial. So we're using this formula, which is the relationship between combination and factorial, to solve this one. So 8 factorial, so it is 8 factorial over 8 minus 5, which is 3 factorial, multiplied by 5 factorial. Good? Now we can start with the 8 factorial. So 8 factorial, take it out of the factorial, you'll still have 7 factorial. Take the 7 out of the factorial, you'll have 6 factorial. Take the 6 out of the factorial, you will have 5 factorial. Keep it there. Do not open the whole thing up to 1. Just stop at 5 factorial. Why? Because we have another 5 factorial in the denominator, so they can simply be cancelled out. The 3 factorial is 3 times 2 times 1. Multiplied by, this is the 3 factorial. The 5 factorial, just keep it as it is. So what I did here, again, 8 factorial, I took the 8 out, so I got 7 factorial. I took the 7 out, I got 6 factorial. I took the 6 out, I got 5 factorial. You can revise this from the previous video. We talked about this as well. Taking things out of the factorial and then reducing the factorial by 1. Now here, 3 factorial is 3 times 2 times 1, and 5 factorial is there. I kept it as it is. And the reason I did that is because it's going to make it easier for me to cancel 5 factorial with 5 factorial. And 3 times 2 is 6. Cancel it with 6. And the answer is still 8 times 7, which is 56. So both answers, or both methods, give you the same answer. You can use any of them, it's fine. Good? Let's check another one. So number 2. Let's check the combination of 8 and 3. And please pay close attention now to the next one. Combination 8, 3. Now, so I'm going to solve it using the first way. So to answer this one, the combination 8, 3 is actually going to be, combination 8, 3 is actually going to be 8 permutation 3 divided by 3 factorial. So 8 permutation 3 is 3 actions, which is 8 times 7 times 6. 3 actions starting with 8 over 3 factorial is a sequence that decreases up to 1 and starts from 3. So it's 3 times 2 times 1. Now notice the following. When we cancel, 3 times 2 is 6. So I cancel it with the 6. I will get 8 times 7, which is 56. So is this a coincidence, getting the same answer in the first example and in the second example? Well, it's actually not a coincidence. There is a certain relationship between these two combinations. And because of that relationship, we got the same answer. Can you figure out the relationship? I'm going to give you a small hint. This relationship lies in the value of r. Do you see the value of r? Here is 3, here is 5. And there is a relationship between these values and the value of n. Maybe some of you have already noticed that 3 plus 5 is going to be equal to 8. So we're saying, like, if we have two combinations with the same n, and r added together will give you that n, then their answer is going to be the same. Is this always true? Let's check it out with something else. So let's do this one, 3. Let's check what is the answer of 9 combination 6. And at the same time, let's also check what is the answer of 9 combination 3. And let's see if these two will give us the same answer. Now notice that 3 plus 6 will give you 9. 6 plus 3 will give you 9. So the value of n is actually the addition of these two. So are we going to get the same answer? Let's see. Now, if we do this one, so 9 combination 6 is actually going to be 9 permutation 6 over 6 factorial. 9 combination 6s are going to be 6 actions starting with 9. So they're going to be 9 times 8 times 7 times 6 times 5 times 4. These are 6 actions starting with 9 over 6 factorial, which is going to be a sequence of the numbers from 6 all the way up to 1. So it is 6 times 5 times 4 times 3 times 2 times 1. And cancelling is going to be pretty easy as well this time. The 6 cancels the 6, the 5 cancels the 5, the 4 cancels the 4. 3 times 2 is 6, cancels, well, we don't have a 6. So the 3 cancels the 9, we get 3. And the 2 cancels the 8, we get a 4. Good? So the answer is going to be 3 times 4 times 7. 3 times 4 is 12, and 12 times 7 is going to be 84. So the answer is 84. So this is going to be the answer of 9 combination 6. Will we get the same answer if we do this one? Let's try this out. So we have here 9 combination 3. So 9 combination 3 is going to be 9 permutation 3 divided by 3 factorial. And 9 permutation 3 means 3 numbers or 3 actions starting with 9. So it is 9 times 8 times 7 divided by 3 factorial is actually 3 times 2 times 1. Now let's start cancelling. We'll cancel the same numbers with the same numbers. 3 with 9 we get 3, and 2 with 8 we get 4. 3 times 4 is 12, and 12 times 7 is also 84. So we've just noticed that this is also the same answer. From this, we can get an important property. And this property is what we call the reduction property. So what exactly is this property? Let's see. So please write this right after writing these examples, the previous examples. So from the last 2 examples, we can get an important property of combinations that is called the reduction property. So what is the reduction property exactly? The reduction property states that if you have a combination of n and r, the answer to this is going to be equal to the answer of the combination of the same n and here n minus r. Okay, what does this mean? Look, in the previous example, we saw combination, or 2 examples, we saw combination 8, 5. Well, what is 8 minus 5? We noticed that this is going to be the same as combination 8, but then 8 minus 5 is 3. So we noticed that combination nr is the same as combination n and n minus r, 8 minus 5, which is 3. This can be the opposite way as well. So combination 8, 3 equals combination n is 8 and n minus r is 8 minus 3, which is 5. So they're equal, right? And the same thing was with combination 9, 6. So combination 9, 6 equals combination 9 is the same and 9 minus 6 is 3. Or we can say in the opposite way that combination 9, 3 equals the same as combination 9, and then 9 minus 3 is 6. So it is always possible. So this is always possible. The way we call it the reduction property is that we usually use this when we have an R that is bigger than half of n. So we reduce it. Why do we reduce it? Because as we saw in the previous example, I think you can see here that it's a lot easier to deal with this one than this one. When we solved combination 9, 3, we got 84 with the multiplication of less numbers than this one. This one was a little bit longer. So it is always useful whenever you have R bigger than half of n to reduce it first and then solve it. Let me show you this with examples. I think the idea will be clearer with examples. But here, we write here that this is a note. This is used. It is used when R is more than half of n. We usually use this reduction property to reduce the value of R, to get a smaller R, and then it's going to be easier for us to solve the problem. And I'll show you this now with some examples. So let's see. Examples or exercises. Exercises. So still evaluate. Evaluate. What they want us to evaluate this time is 1 combination 50, 48. 50, 48. Okay, so let's see. Answer. If we solve this directly, this is going to be a combination of 50, 48, which is going to be 50 permutation 48 over 48 factorial. This is going to take us forever, because we're going to have to write 48 actions that start with 50. And in the denominator, we need to write 48 factorial. That's a big number. And actually, this whole sum, this whole fraction is quite big. So instead of doing this, we're actually not going to do this. Instead of doing this, we will attempt to reduce it first. And can we reduce this? Of course we can. Or we can say that this is combination 50, and here we write 50 minus 48. N minus R. N minus R is 50 minus 48. And 50 minus 48 gives you 2. This combination and this combination will give you the same answer. So instead of working with this one, complicated one and a long one, we can simply work with this one, which is a lot easier, which is here 50 permutation 2 over 2 factorial. Do you see the difference in the numbers? Now 50 permutation 2 means two factors only, which are 50 times 49, 2 factors or 2 actions divided by 2 factorial, which is 2 by 1. And now we cancel whatever is possible. We can cancel the 2 with the 50. Yes, we will get 25. So we have 25 times 49. And this, of course, is going to be a lot smaller number than the number that we were going to start with, or the process that we were going to do here. The answer here is going to be 1225. So getting this answer from here is a lot easier than getting the same answer from here. So as you've noticed, it's always useful to use this reduction property whenever R is more than half of n. Half of n is half of 50. What is half of 50? It's 25. 48 is a lot more than 25. So it is a lot better to reduce it in this case. Whenever R is more than half of n, it's always better to reduce it. Let's give you another example. Let's look at this one. So 2. Let's say that you have a combination, and this combination is, for example, 25, and here, let's say 21. So What's half of 25? Half of 25 is 12.5. This is 21. It's a lot bigger. So in this case, it is always useful to reduce it right away. So let's reduce it. So it's going to be combination of 25 as it is, but R is going to be 25 minus 21. And 25 minus 21 gives you 4. Now this combination and this combination will give you the same answer. But this one is a lot easier because we only have 4 as R. So it's going to be 25 permutation 4 divided by 4 factorial. And this is going to be 4 actions starting with 25. So it's 25 times 24 times 23 times 22 divided by 4 factorial, which is 4 times 3 times 2 times 1. Now we'll cancel whatever we can. Of course, we can cancel the 4 with the 24. We will get 6 out of it. And then the 3 times 2 is actually 6. So we cancel the 6 with the 6. So what are we left with? We are left with 25 times 23 times 22. And the answer to that is going to be 12,650. So this is going to be the answer of this combination. So this is now the reduction property of combinations, and this is how we use it. We can pause now for a little bit, and then we will come back with more properties and more examples. Okay, so we're back now with the same title, same lesson, which is Combinations. And some more exercises of evaluating. And from these exercises, we will try to investigate some more properties of combinations. So let's look at this exercise. Evaluate the combination of 35, 35. Okay. So this one's interesting. You notice that here we have 35, 35. So it's R is already bigger than half of n. So in this case, we need to reduce it. And let's try to reduce it. So this is going to be the combination of, 35, and in the place of R, we will subtract them. So 35 minus 35 will get 0. But how much is that exactly? Okay, actually, whether you try to solve it this way or you try to solve it the other way, this is going to be quite easy both ways, and we will see now why. Now look at this, guys. If you try to solve it this way, this is going to be 35 permutation 0 over 0 factorial. If you try to solve it this way, this is going to be 35 permutation 35 over 35 factorial. Okay. From the previous lesson of permutations, let's just remind you a little bit here. From the previous lesson of permutations, we've learned that n, permutation n, is actually equals to n factorial. And we have already also learned that n, permutation 0, is actually equals to 1. I hope that you can refer back to the video of the previous lesson and remind yourself with these two important formulas or these two important properties if you don't remember them. So n permutation n is actually n factorial. N permutation 0 is actually 1. And from the lesson before, I think we talked about this in the class. We talked about 0 factorial being equal to 1. I gave you this once when I gave you the list of factorials at the beginning of the lesson of permutation. So using these properties, we can get the same answer from both methods here. Let's see how. If we're using this method, so 35 permutation 0 is actually n permutation 0, and that's going to be 1 over 0 factorial, that's 0 factorial, which is 1, and 1 over 1 is equal to 1. So the answer is 1. If we use the other way here, n permutation n is actually n factorial, so we will get 35 factorial divided by 35 factorial. And now if we cancel these two together, so when we cancel them together, because it's exactly the same factorial, so when we cancel them together, we will get also 1. Okay? So the answer, whether using this method or using that method, whether by reducing the value of r or keeping the value of r as it is, the answer will be 1. And this draws us to an important property. So, property. This property states the following. In combination n is equal to in combination 0, which is equal to, both cases, it's equal to how much? It's equal to 1. So whether it's n combination n or n combination 0, the answer will be 1 either ways. So this is an important property of combination. And please always try to compare this to this one. Notice that these two are not equal in permutation, but they're equal in combination. N and n0 are not equal. They give you different answers. N factorial here and 1 here. But with combinations, they both give you the same answer, which is 1. So this is a key difference between combinations and permutations. Notice that in permutation 0 and in combination 0 is the same thing. It is 1. Okay? But in combination n is different than in permutation n. This is going to be 1, this is going to be n factorial. So these are different. Okay, good. Now, let's carry on. Let's do another one of evaluating. And with it, we will also discover another property. Let's say that we want to find the combination of 9 and here 1. So the value of r is how much? It's 1. So let's do this. So answer. We can do this by referring to the relationship between combination and permutation. So this is n 9 permutation 1 over 1 factorial. And here I'll need to remind you of this one. So if you have n permutation 1, how many actions do you have? You have 1 action. And how much is that action? It is n. So n permutation 1 is equal to what? It's equal to n. So here, when we attempt to solve this one, 9 permutation 1 is actually going to be equals to 9. So this is 9 in the numerator over 1 factorial is 1. And 9 over 1 is going to be equal to 9. So combination 9, 1 equals to 9. So generally, we can say, we can actually write this property. This is an important property. And here also we can write that we have this property. And what is this other property? We can say that in combination 1 is equal to n. And in this sense, it's actually similar to the permutation. So in permutation 1 was equal to n. In combination, it's quite the same. In combination 1 is equal to n. Good? So these are important properties. The reduction was number 3, this is number 4, and this is number 5. And always remind yourself with these comparisons between combinations and permutations. Always compare them to each other to notice the differences. These are important differences. Okay? So, actually in the lesson of combinations, we have 8 properties. So we are left with 3 more properties. and we will discuss them now after a brief pause. Okay, so let's continue now. Just to remind you, we're still with the lesson of combinations. So far, we have discussed 5 different properties of combinations. And now, let's look at the 6th one. So property number 6. Let's say that we need to find the ratio of two consecutive combinations. Let's say that we want to find the ratio of 2 consecutive combinations. What do we mean by that? Let's see. Let's look at this through an example. So, exercise, simplify the combination of NR ratio to combination of NR minus 1. Let's see. Actually, by simplifying this one, we're going to find an important property. And let's investigate it together. So let's see. What do they want us to do? They want us to simplify this combination ratio to this combination. Now, the word ratio means division. Okay? So, let's do the answer. And to be frank with you, this answer is best to be done through the relationship between combinations and factorials, not combinations and permutations, no, between combinations and factorial, because in that sense we can cancel stuff together, and I'll show you now how. So let's see. We know that from the property number 2 that the combination of NR is equal to N factorial over N minus R factorial times R factorial. This is the relationship that we talked about at the beginning of this class. It's the relationship between combinations and factorials. So let's apply this relationship here. So this one is directly the rule. It's just the rule exactly. So combination NR is N factorial over N minus R factorial multiplied by R factorial. Okay, so it's straightforward. The ratio sign is actually a division sign. We've discussed this before also in the previous class of permutation. The ratio sign is actually a division sign. Now here, it's the same formula, but notice that R is not the same as the formula. The formula says R. Here we have R minus 1. How do we deal with that? Well, it's easy. Look at this. In the numerator, if you have n, you write n factorial. What do we have here? We have n, so we will write n factorial. In the denominator, we start by n minus r, which is this minus this. So you subtract n minus this one. So here we don't have r, we have r minus 1. So we'll just subtract them. So it will be n minus r plus 1. Now, why is this plus? Why isn't it minus? Because we want to subtract this minus this. The minus is for both of them. So the minus for the r is minus r, and the minus for the minus 1, minus and minus becomes plus 1. So just be careful. Here, what you are actually doing is you're taking n minus r minus 1. You're subtracting the whole thing. So when you subtract both terms, it's going to be n minus r, and minus times minus is plus, so plus 1. The minus, the subtraction, is for r, it means for both of them. So you subtract both of them, so it's minus r plus 1. Minus and minus is plus, so it's plus 1. Times r factorial. Well, this r is actually taken from here. R factorial. We don't have an r here. What do we have? We have r minus 1. So we'll write here r minus 1 factorial. So this is the way that we're going to open this one. I know it seems complicated at the beginning, but it's really easy. With time, you just get used to it. What are we doing exactly? We're putting this factorial over this minus this. N minus r minus 1. So it's n minus r plus 1, because minus and minus becomes plus, times r factorial. Now what do we do next? As usual, this is a keep, a change, and a flip. So we keep the first fraction as it is. So it's n factorial divided by n minus r factorial times r factorial. And then divide. The divide becomes multiply. And then we flip this one. So let's flip it. So when we flip it, we will get n factorial in the denominator. And in the numerator, we will have n minus r plus 1 factorial multiplied by r minus 1 factorial. Good. Can we cancel anything? Look closely at it. You see that we have n factorial here and n factorial here. These can be easily cancelled with each other. Okay, now, what about the rest? Well, the only thing we can do with factorials is to cancel them whenever they are equal, whenever they are the same. Otherwise, we can take something out and reduce it by 1. So if you have n, you take it out, you get n minus 1. You take it out, you get n minus 2, and so on. Now look at this, guys. This is n minus r factorial. This is n minus r, the same thing, plus 1. Which one is bigger? This one is bigger, because it's plus 1. This is n minus r only, but this is n minus r plus 1. So what are we going to do? We will actually take this out. And when we take this out, we will reduce the factorial by 1. So when you minus 1, you will get n plus r only. It was n plus r, n minus r plus 1. You will reduce 1, so it will be n minus r. So let's do that. So here, you take this out. Of course, this is 1. So you take n minus r plus 1 out. That's out of the factorial. Then times, the factorial will be n minus r factorial only, because you will reduce the 1. Times r minus 1 factorial over, in the denominator, now notice that we have n minus r factorial, which is a match with the numerator. This one is a match with the numerator. I can cancel it. But the r here, r is bigger than r minus 1. This is bigger, r. This is r minus 1. So this one is bigger. So let's take it out. If you take it out of the factorial, you will subtract 1 from it. So it will become r minus 1. So you write r outside the factorial, and then times r minus 1 factorial. You reduce 1 from it. Okay, now let's cancel. We can cancel this one with this one, and we can cancel this one with this one. So what are we going to get now? We will get n minus r plus 1 over r. So actually, combination n r ratio with combination n r minus 1 is equal to this fraction. And this is actually the 5th property, or the 6th property, I'm sorry. If the proving was a little bit hard, then always remember that your exam is a multiple choice exam. You don't really need to know how to prove it, but you need to know how do you use it. So this is an important formula now. This is number 6. Of course, I prefer that you know how to prove it. But if it's just hard, you can skip this part and just put this in your mind. You have to memorize this one. So this is how do we find the combination, the ratio of combination n r minus 1. These are consecutive. These are after each other. So the answer is this, like this. However, this one can be sometimes deceiving. In some exams, they don't actually give you this ratio. They might give you another ratio. They give you combination R, n r plus 1 to combination n r. Okay. Are these consecutive? They are the same as this one. The meaning of consecutive, they're after each other by 1. So you reduce one, you get the other one. Look, here it's the same n. It's the same n. But when you look at r, this is r minus 1. So it's consecutive after it, right after it. The same thing here. It's the same n. But r, this is what? R plus 1, this is r. So it's the same thing. They're consecutive. But this time, we're starting with r plus 1. We're not starting with r. Will you have a different answer? Yes, you'll have a different answer. How is that? It's quite easy. Look. Let's compare between this one and this one. What did we write here? We wrote n. So we wrote this number. Right? We wrote it here. Minus r. R was which one of them? Was it this one or was it this one? It was this one, the bigger one, right? It was the bigger one. So n minus r. And then I added 1 over r. R is still the same as this one, right? So it's the bigger one. So if you want, with the same sense, to write this ratio, what are you going to do? First of all, this one here, you will write at the beginning of the fraction. So it will be n minus. And then you will write this one, the bigger one. You write it next. The same as here. You wrote r next, you write r plus 1 next. When you write r plus 1 and there is a minus, this minus is for both of them. So it will be minus r minus 1. It's for both of them. Minus times r is minus r and minus times 1 is minus 1. And then you will add a plus 1 over, you will write this one. Look, here, this r comes in the denominator, right? The bigger one comes in the denominator. So you write this one in the denominator. So it becomes r plus 1. Now here you can cancel the negative one with the positive one. So you get something like this. A combination of n r plus 1 to combination of n r equals n minus r, since the minus 1 and the plus 1 are cancelled, over r plus 1. And this is now another relationship. This is in case it's written like this. In case it's written like this, you get this relationship. So this is also the ratio of two consecutive combinations. But I really need to stress on this. This is the main rule. If you know how to write the main rule, then think carefully how do you apply it with other consecutive terms. I just showed you here, how do we apply this rule? How do we apply this rule here? Look at this, guys. This side here, the right-hand side, the one that I'm erasing now, is not constant. No, it depends on this side. So whatever you have in this side will affect this one. What you need to have here is a ratio of two consecutive combinations. This is important. They have to be consecutive, and it has to be division. Now what you have here is this one first, the bigger one second, plus 1 over the bigger one. So it's always, the formula is like this. It is the n, you can write this as a note. It is n, the n minus the bigger r plus 1 over the bigger r. N minus the bigger r of the two plus 1 over the bigger r. The same thing, n minus the bigger r of the two was this one. Plus 1 cancelled the negative one over the bigger r. So this is mainly the sixth property. This is the combination of n r and n r minus 1. Please pay attention. In this class, we will mainly concentrate on properties, on these properties. I'll give you the properties, but then in the next class, we will see how do we put these properties into action, into some real problems. I'll pause now a little bit, and then we'll come back with the seventh property. Okay, now let's look at the seventh property of combinations. Now, this property was actually discovered by a Muslim scientist named Al-Kirchi. So what is this property? He called it after his name, so now it is famous for Al-Kirchi's relation, or Al-Kirchi's relation in English. So this is property number 7, which is Al-Kirchi's relation. Okay, in the previous property, we saw the ratio between two consecutive combinations. And the ratio was the division. Al-Kirchi's relation, or Kirchi's relation, is actually a property in which we will investigate the addition of two consecutive combinations. So combination n r plus combination n r minus 1. You see, these are consecutive combinations. The same n, r are consecutive. And between them, there is a plus. In the previous property, there was a division. Now this time, it's a plus. So what does this property say? It says simply that here in this one, it is equal to one combination in which you add 1 to the n. So it's n plus 1. And here, you select the bigger r. Which one is the bigger r? It is r. So it's simply like this. So combination nr plus combination nr minus 1 equals combination n plus 1 and r. This is property number 7. And as an example for this, we can see that if you have a combination of 7, 5 plus combination of 7, 4, then the answer is going to be the same as combination 8, and you select the bigger r, which is 5. And if you work these out, if you evaluate these two and you add them, you will find out that this is the same as this one. I'm not going to try this out actually. If you have the power, you can try it out. But the point is, you just add 1 to the n and you select the bigger r. But they have to be consecutive. They have to be after each other. You select the bigger r, which is 5. Another one, combination n plus 1, r plus 1 plus combination n plus 1 and r equals. So what do? We add 1 to the n. So instead of being n plus 1, it will be n plus 2. And the r will select the bigger one. The bigger one will be r plus 1. Good. So this is also another example. And let's end it with the last property. Remember that in this class, we'll mainly focus on the properties of combinations. In the next class, inshallah, in the next video, we will solve a lot of examples with these properties. So the last property is the equality property. Okay, what does this property say exactly? So this property says the following. It says if you have two combinations, n and r1, and it's equal to another combination, n or r2, you have two equal combinations with different r's, then either r1 and r2 are equal to each other, this is the same number, or r1 plus r2 is equal to n. this is somehow related to the reduction property. And I'll show you now how. What does this mean exactly? Look at this, guys. Let's say this is an exercise, and this is going to be our last exercise in this lesson. So, an exercise, we want to find the value of R. And we are given that combination 8, 5 equals combination 8R. So how much is this R, you think? This is the same as the example I gave you, which is 8, 5, and 8, 3. So you can say here, look, if two combinations are equal and they have the same n, but they have R's, different R's, 5 and R, then the answer is, you say directly that either this one and this one are equal, so either 5 is equal to R, so this is R is equal to 5, or R1 plus R2 is equal to n, so 5 plus R is equal to 8. 5 plus R is equal to 8. If you transpose the 5 to the other side, R is equal to 8 minus 5, and that means that R is equal to 3. So it's either R is 5 or R is 3. So it's either this one is a combination 8, 5, so they're equal to each other, or this one is combination 8, 3, so they're equal to each other according to the reduction property. I hope that you understand this last bit, and with this we're going to be done with 8 properties of combinations. And we will also be done with this lesson, so I'll not leave you without homework, so please just make sure to do this homework. It's an easy homework this time, since the main homework that you have for this lesson is to memorize the formula as well, because the next lesson is going to be demanding. You will not get the next lesson easily if you don't know the properties well. So please, you need to revise the properties well, and your homework is on exercise 2-3, the one I showed you at the beginning of this class. Question 1, I need you to solve B, C, D, and E. There are 4 simple questions of evaluating. Try to apply as many properties as you can in these questions, and we'll see you inshallah next class. Stay healthy, stay safe inside your homes, and see you next time inshallah.